In this section, we're going to be talking about complex numbers. So objectives, we're going to perform arithmetic operations on complex numbers and solve quadratic equations having complex solutions. So here in this graph, we have this graph right here, which is the x squared minus x squared plus 1. It's the same from the previous lesson. And if you notice again, it does not cross the x-axis. So when we set it equal to 0, our answer is no x-intercepts. Now in this section, we're actually going to come up with two answers. And again, the key thing here, why 2? Because we have an x squared. And the fact that it doesn't cross the x-axis, we know that we're going to have two imaginary answers. Now, to help us do that, we need to know this right here. So we're going to have an imaginary friend. We're going to call it I. And I is technically equal to the square root of -1. And we also need to know that if we do I squared, we're going to get an answer of -1. And let me show you here. If I start off with I equal to the square root of -1, and I decide to square both sides, then I'm going to get that I squared is equal to, so the square root and the squared cancel each other out. So I'm left with a -1. All right. So it says, remember that we must let y equal to 0 to find the x-intercepts. So if we let the equation y equal to x squared plus 1 be equal to 0, we're going to get 0 is equal to x squared plus 1. And if we're going to solve for x, we're going to subtract 1 from both sides. Then I'm going to come over here. 0 minus 1 is -1 is equal to just x squared, because these simplify to 0. And to get rid of a squared, I'm going to take the square root of both sides. And on the right hand side, the squared and the square root simplify, they cancel each other out, they're inverses of each other, so I'm just left with x. And we need to remember that the square root of -1 is going to be, we can't forget, we're taking the positive and negative, and the square root of -1 is going to be I. And here, if we have a being a positive number, then the square root of -a is technically I square root of a. And this is the reason why. Because this is going to be the square root of -1 times a. And the square root of, I'm going to break it up into two pieces. Square root of -1 times the square root of a. And the square root of -1 is I, and then square root of a. And that's the reason why we have that identity there. So let's do some examples. So examples, simplify each expression. So here the key thing, since we're just doing square roots. So for square roots, sorry for the background noise. So for square roots, we're looking for perfect squares. So when we have perfect squares, we're gonna be able to take the square root of it and simplify it. So for square root of 32, we might not know. So there's two things that we can do. So it'd be nice, the quickest way, so I'm going to put here option number 1, is technically to do, square root of -32, I know it's going to be -1, times, and then square root of 32, I can make it as 16 times 2, because 16 times 2 is 32. And I love 16 because the square root of 16 is 4. So here on this one, I'm going to have square root of -1. Then I'm going to have times the square root of 16 times the square root of 2. So the square root of -1 is I. The square root of 16 is going to be, so times 4. And square root of 2 is but ugly, so we'll keep it at square root of 2. And really the correct notation is that we're going to do 4 and then I and then square root of 2. Now, let's say that you're like, I would have never have thought of 16. Well, then what you need to do from your previous knowledge is the prime factorization tree. So if the first thing that came to your mind, 32 is 4 times 8, that's fine. And then you need to break it down. So 4 is 2 times 2, and then 8 is 2 times 4. And then we have that 4 is 2 times 2. So then here, we would have seen, hopefully we understand that 32 is equal to 2 times 2 times 2 times 2. And then we would have said, oh, well, this one is 4. And then this one is 4. And then the 4 times the 4 would have given us the 16 that we need right there. So the next, so I guess I could put this as an option number 2. All right. The next one. So the next one says negative 2 plus or minus the square root of 36 over 6. So this one we need to know that the square root of 36 is technically 6. And so this is going to be negative 2 plus or minus 6 over 6. And we need to realize that we have two answers here. This is going to be negative 2 plus 6 over 6. And the other one is going to be negative 2 minus 6 over 6. So negative 2 plus 6 is going to be 4/6, which simplifies to 2/3. And then this one's going to be negative 8/6, which simplifies, they're both divisible by 2, so negative 4/3. So we have our two answers right there for this one. Again, because we have the plus or minus. All right, the last one. So the square root of negative 20, again, the easiest way would be nice to say, okay, so square root of negative 20 is negative 1 times 4 times 5, because the square root of 4 is a beautiful 2. And then times the square root of negative 1 times 5. And so here, let's break this part. This one right here is technically going to be the square root of negative 1 times the square root of 4, which is 2, and the square root of 5, which is but ugly. And then this part right here, we're going to put the times here for this one. Square root of negative 1, I could have just put I, but I didn't. And then times square root of 5. So the square root of negative 1 is I. And then I have times 2 square root of 5 times, this is another I. And then this is times the square root of 5. So combining like terms, I'm going to do another color here. So if I do I times I get I squared. And then if I do square root of 5 times the square root of 5, I'm going to get the square root of 5 squared. And then I have this poor times 2 by itself over here, times 2. So what is I squared? I squared is negative 1. Times, what is the square root of 5 squared? So again, the square root and the squared are inverses of each other. So they cancel each other out. So I'm just going to be left with 5. And then times 2. And so negative 1 times 2 is negative 2. And negative 2 times 5, my final answer to this is negative 10. Now, the standard form of a complex number here is a plus bi. So this is important to know. A is the real part, and this bi is the imaginary part. So adding, subtracting, and multiplying complex numbers is nothing new. Just treat the I as a variable and simplify at the end if possible. So in division, we actually multiply by the complex conjugate. And here, this is important to note, the complex conjugate of a plus bi is technically the a and the bi, but instead of a plus in between them, it's a minus. And so number 1 says, write each expression in standard form. Support your results using a calculator. All right, so we have negative 2 plus I, and then 1 minus 2i. So I'm going to distribute here. Negative 2 times 1 is negative 2. Negative 2 times negative 2i is a positive or plus 4i. And then I times 1 is plus 1i, which I'm just going to put the 1i there. And then I'm going to have I times a minus 2i is going to be a minus 2i squared. And then I'm going to just collect like terms here. So this is going to be negative 2. And then these two, I have 4 i's plus another I. I'm going to have 5 i's. And then this is going to be negative 2. And then we need to remember that the I squared is negative 1. So this is going to be negative 2 plus 5i. And then this is going to be plus 2. And so the negative 2 and the plus 2 simplify to 0. And my final answer is 5i. I leave it up to you to check on your calculator. The next one. So I have 1 minus I divided by 2 plus 3i. So here on this one, I need to make sure that we understand that we're dividing. So then I need to do this. I'm going to do 1 minus I divided by 2 plus 3i. And this right here, we actually multiply by the complex conjugate. So I'm going to highlight this, and I'm going to show it right here. So I need to multiply by the complex conjugate. So if I have 2 plus 3i, then the conjugate is going to be 2 minus 3i. And I'm going to highlight all of this. And what I do to the numerator, I need to do to the denominator. So it's going to be the same, 2 minus 3i. And I'm going to be putting parentheses here, even though they're not there. And then I'm just going to FOIL the numerator, and I'm going to FOIL the denominator. So here I go. Maybe I should start more over here, just in case. So here I go. So I'm going to come right over here. So this is going to be 1. So I'm going to have my huge fraction bar. And I'm going to do 1 times 2. Excuse me, is 2. And then I'm going to do 1 times a minus 3i. Minus 3i. And then I'm going to do a minus I times 2. It's going to be minus 2i. Excuse me. And then a minus I times a minus 3i is going to be a plus 3i squared. Now I'm going to do the denominator. So 2 times 2 is 4. 2 times a minus 3i is a minus 6i. And then I have 3i times 2 is going to be a, plus 6i. And then plus 3i minus 3i is going to be minus 9i squared. And now we just simplify. So this is going to be on the numerator. The 2 doesn't combine with anyone yet. But the minus 3i and the minus 2i becomes minus 5i. And then this is going to be plus 3 times, and I can't forget that the I squared is negative 1. Now in the denominator, I'm going to have 4. And then the minus 6i and the plus 6i simplify to 0. And the minus 9i squared is going to be minus 9 times 1 squared. Excuse me, negative 9 times I squared is negative 9 times a negative 1. Then I'm going to come over here. So in my numerator, this is going to be 2 minus 5i, and then a plus 3 times a negative 1 is going to be minus 3. And then 4 minus 9 times negative 1, so a minus times a negative is a positive, but I'm going to write it as a plus. And I get 4 plus 9. And so combining like terms on the numerator, 2 minus 3 is going to be negative 1. Minus 5i, and 4 plus 9 is 13. Now, we need to rewrite it in this form. So the real part, and then plus or minus the imaginary part. So from our fraction days, we need to remember that I can break this up into 2 fractions. This is going to be negative 1 over 13 minus 5 over 13 I. And so here is our answer for that one. Okay, quadratic equations having complex solutions. So we need to remember that there are three types of outcomes. We can have exactly two real solutions. We can have one, or we can have no real solutions, which are technically two imaginary roots. We need to remember that they travel, remember that complex, otherwise known as imaginary, solutions travel in pairs. Why in pairs? Again, because of the plus minus part. And we'll see. Now, if you are interested in solely using the quadratic formula, then this part right here that's inside the square root is called a discriminant. So right here. And so if what's inside the discriminant is greater than 0, then you're going to have two real solutions. If the discriminant is exactly equal to 0, then you're going to have one solution. And if the discriminant is less than 0, you have no real solutions. And again, using the quadratic formula, it works all the time. You just have to remember it. Now, sometimes we don't have to use it. So here, examples solve the quadratic equation, support your results graphically. If I'm going to use the quadratic equation on this question number 1, we need to remember that the a is 4. And let me just highlight it here. So the a is 4, and it's because of that 4. We need to remember that the b is technically 0 because we're missing an x. X is missing. And then our c is equal to the positive 3 because it's right there. So this plus 3 is that 3 right there. And then we need to remember that x, the formula is up there up at the top. So Murga likes to put parentheses wherever she sees a variable. And so it's going to be negative b, so it's going to be 0. And it's going to be plus or minus b squared, which is 0 squared, minus 4 times a, which is 4, times c, which is 3, all over 2 times a, and that's that 4. And then you can use the calculator again, or the noodles that God gave you. So plus or minus. So 0 squared is 0, and then 4 times 4 is 16, and then 16 times 3. Put a 1 here, and we get 48. I was already thinking of the answer. We get 48. But technically, you can do negative 48, but I'm gonna rewrite it as, because since I already have 4 times 4 there, I know that this is gonna be negative 16 times 3. Excuse me. All over 2 times 4, which is 8. And so I'm going to get x is equal to, so negative 0 is just 0. So positive or negative. So the square root of 16, so I'm going to put this here. This is going to be the square root of negative 1 times 16 times 3. So the square root of negative 1 is I. And then the square root of 16 is 4. And we like to put it there. And the square root of 3, well, is but ugly, so it stays inside the radical. All right, so then we have all over 8. So we need to realize that, let me highlight here in another color, this 4 and this 8 are both divisible by 4. So what's 4 divided by 4? Technically, I have a 1, square root of 3, and 8 divided by 4 is 2. So if I ignore the 1, it's just going to be plus or minus square root of 3 over 2. And I can't forget the I. So this I right here that I forgot, let me highlight it because I forgot it to make sure that we don't forget it anymore. Let me put it right here. So this I that I forgot, make sure that I put it here and I put it there. So here's my I, and 1 times I is just I. So plus or minus I square root of 3 over 2. So here we go. All right, now, hopefully some of you would have said, you know what, Murga, we really don't need to do this. I only have an x squared, so I can use the square root property. So this was using the quadratic formula. And here I'm going to just use the square root property. So here I go. So I could have just subtracted 3 from both sides. Sorry about that background noise. And then I have 4x squared is going to be equal to 0 minus 3 is negative 3. And then I'm going to have, divide by 4, because I'm multiplying by 4. So I'm going to divide by 4. I wanted it in hang tight. Oops. So I'm going to divide by 4. And so I'm going to be left with x squared is equal to negative 3/4. To get rid of the squared, I'm going to take the square root of both sides. And I'm going to get x is equal to, and I can't forget, since I took the square root both sides of an equation, it's going to be plus or minus square root of 3/4. Well, I'm going to do it step by step. 3/4, which technically is, sorry about that. X is equal to, so the square root of 3, and I drop a negative. I inherently drop negatives all the time. So that means I can't owe money. Okay, so anyway. So square root of negative 3 is going to be the square root of negative 1 times 3. So it's going to be plus or minus. So the square root of negative 1 is I. Square root of 3 is but ugly. And then the square root of 4 is just going to be a 2. And if you notice, we get the same answer a lot quicker. All right, number 2. Solve the quadratic equation again, and you can support your results graphically. So for this question number 1, if you take the time to graph it, you're gonna see that it doesn't cross the x-axis, and no graphing utility will give you the imaginary answers. So we got to do it algebraically. All right, number 2. It says negative x times 7 minus 2x equal to negative 6 minus 3 minus x. So we need to distribute. So negative x times 7 is negative 7x. Negative x times a minus 2x is plus 2x squared. And then we're going to have is equal to a negative 6. And then this minus times a 3 is minus 3. And this minus times a minus x is plus x. So we could put the left side on the graphing utility and then the right side again on the graphing utility. But we're going to do it algebraically. So I'm going to move, I'm going to set everything equal to 0. And so I'm going to move, well, first I'm going to combine like terms. So negative 7x plus 2x squared don't combine, so I just copy everything. And negative 6 minus 3 is negative 9 plus an x. So now I'm going to move everything because I want it equal to 0. So to get rid of a minus 9, I'm going to add 9. And it doesn't combine with anything, so I'm going to put it over here in the boonies. And then I'm going to subtract x from both sides. and it's going to align with the minus x. And I get equal to right here. And so I'm going to start putting them in descending powers of x. So the 2x squared is first. It doesn't combine with anything. Minus 7x minus an x is minus 8x. And then plus 9 is equal to, and everything over here just cancels out or simplifies to 0. So I could spend some time trying to see if it's factorable. I know I can't, a 2 and an 8 and a 9 don't have anything in common other than 1. And I can see if it's factorable, but I'm going to tell you right now it's not. And so the process that always works is either completing the square or using the quadratic equation. So here, I'm going to do the quadratic. So a is equal to 2, the b is equal to negative 8, and the c is equal to 9. And so x is equal to negative b plus or minus b squared minus 4 times a times c all over 2 times a. So Murga's going to substitute stuff in. So it's negative b, which is a negative 8, and then negative 8 squared minus 4 times a, which is 2, times c, which is 9, over 2 times a, which is 2. And again, you can use a calculator. On a good day, negative 8 is just positive 8, plus or minus square root. So if I do parentheses negative 8, parentheses squared minus 4 times 2 times 9, you're going to get, negative 8 over 2 times 2, which is 4. Now, please don't take my word about these calculations that we're doing, that we should be doing with the calculator. Just in the interest of time, just make sure that you know how to manipulate your calculator to get these answers, because if not, that's going to be the problem. So please practice. Okay, so now we need to know that here, I'm going to do this. Square root of negative 8 is technically the square root of negative 1 times 4 times 2. And so the square root of negative 1 is I, the square root of 4 is 2, and the square root of 2 is but ugly, so it stays square root of 2. So now I'm going to rewrite it as follows. So it's x equal to 8 plus or minus 2i square root of 2. I got it from here, putting it in the correct representation, over 4. Now I'm going to come over here, since I'm not quite done. We need to realize that, let me highlight here, this 8 and this 2 are both divisible by 2. That means that I can factor a 2 out. So that's what I'm going to do. So it's equal to, so this is I'm going to factor out a 2. So 2 times what gives me 8? Well, on a good day, 4. And then I'm going to have plus or minus. And 2 times what gives me 2i square root of 2? On a good day, just I square root of 2. And this is going to be over 4. Now, since I have these two, 2 and 4 are both divisible by 2. So, or you can just say, oh, 2/4 is a half. That's fine. So this is x is going to be equal to, technically an understood 1, parentheses 4 plus I square root of 2 over 2. But the most simplified answer would be 4, and I forgot the minus here. So 4 plus or minus I square root of 2 over 2. Now we want to break it up into the real and the imaginary part. It would be it's equal to 4 over 2 plus or minus I square root of 2 over 2. And so 4 divided by 2 is 2. And it's going to be plus or minus I square root of 2 over 2. And so how many answers do we have? We have 2 answers. because of the plus minus. So let me show them to you here. It's 2 plus I square root of 2 over 2. And the other one is 2 minus I square root of 2 over 2. And our last question here, it says use the graph to predict the number of real zeros and the number of non-real complex zeros. So non-real complex zeros is a big name for the imaginary ones. All right, so the graph doesn't touch the or cross the x-axis, so the number of real zeros is none. So let me write that down. And the number of non-real complex zeros is 2. Again, remember, because they travel in pairs. Now, another thing we need to start seeing, that this is technically a parabola. And how can we tell? Because it's an x squared. And so the total number of x-intercepts, so let me put this here. Total number of x-intercepts, which technically are x values of our x-intercepts or our zeros, I should put x values of x-intercepts. Let me fix this here. Should equal to 2. And why is it going to be equal to 2? Because this 2 better is this 2. Now, using our answer, there's no reals, so that's going to be 0. And the number of complex zeros is 2. And 0 plus 2 is, in fact, that 2.